Problem on trains, one of the most familiar section for quantitative aptitude. So before going ahead and solving some problems, let's first look at some important formulas. Conversion of kilometer per hour to meter per second. A kilometer per hour equals to A into 5 by 18 meter per second. Here what we have done, we have first converted kilometers into meters and hours into seconds. 1 kilometer equals to 1000 meter and 1 hour is equal to 3600 seconds. Then by cancelling both the terms, we are getting A into 5 by 18 meter per second. Similarly, let us see meter per second to kilometer per hour conversion. A meter per second equals to A into 18 by 5 kilometer per second. Here also we have first converted meters into kilometers. 1 meter equals to 1 by 1000 kilometer and 1 second equals to 1 by 3600 hours. Then by simplifying the terms, we are getting A into 18 by 5 kilometer per hour. Next formula. Time taken by a train of length L meters to pass a pole or standing man or a signal post is equal to the time taken by the train to cover L meters. Next formula. Time taken by a train of length L meters to pass a stationary object of length B meters is the time taken by the train to cover L plus B meters. Next formula. Suppose two trains or two objects or bodies are moving in same direction at U meter per second and V meter per second, where U greater than V, then their relative speed is U minus V meter per second. Similarly, suppose two trains or two objects or bodies are moving in opposite direction at U meter per second and V meter per second, then the relative speed is U plus V meter per second. Next formula. If two trains of length A meters and B meters are moving in opposite directions at U meter per second and V meter per second, then the time taken by the trains to cross each other equals to A plus B by U plus V seconds. Next formula. If two trains of length A meters and B meters are moving in the same direction at U meter per second and V meter per second, then the time taken by the faster train to cross the slower train equals to A plus B by U minus V seconds. Next formula. If two trains or bodies start at the same time from point A and B towards each other and after crossing they take A and B seconds in reaching B and A respectively, then A speeds equals to B speed equals to root B is to root A. Now let's see some examples. A train 125 meter long passes a man running at 5 km per hour in the same direction in which the train is going in 10 seconds. The speed of the train is, the options are 45 km per hour, 50 km per hour, 54 km per hour or 55 km per hour. The right option is option B, 50 km per hour. Let's see the explanation. The relative speed of the train equals to 125 meters per 10 second, because 125 meters is the length of the train and 10 seconds is the time it takes to cross the man. That is equal to 25 by 2 meter per second. That is also equals to 45 kilometers per hour. We have just converted meter per second to kilometers per hour. Now let the speed of the train be x kilometers per hour. And it's given that the man's speed is 5 kilometers per hour. Now as we know that the relative speed of two moving objects which are in the same direction U and V is equal to U minus V, then relative speed will be x minus 5 km per hour, which is equal to 45. That gives x equals to 50 km per hour. So the train speed is 50 km per hour. Next question. The length of the bridge which a train 130 meters long and traveling at 45 km per hour can cross in 30 seconds is, options are 200 meters, 225 meters, 245 meters or 250 meters. The right answer is option C, 245 meters. Let's see how. In this case, first let's convert 45 kilometers per hour into meters per second. That is equal to 25 by 2 meters per second. Now the given time is 30 seconds. So here let the length of the bridge be x meters. Then the total distance that the train need to cover is the total length of itself with the length of the bridge. That is equal to 130 plus x. Now the time is 30 seconds. So let's divide 130 plus x with 30 seconds. That is equal to 25 by 2. To make it more simpler, the speed 25 by 2 equals to the total length that the train needs to cover, that is the length of the train itself with the length of the bridge by the time given. Then by simplifying this equation, we are getting 2 whole into 130 plus x equals to 750. That implies x equals to 245 meters. So the length of the bridge is 245 meters. Next question. Two trains running in opposite directions cross a man standing on the platform in 27 seconds and 17 seconds respectively, and they cross each other in 23 seconds. The ratio of their speed is 1:3, 3:2, 3:4 or none of these. The option is option B, 3:2. Let's see how. Now here let the speed of the two trains be x meter per second and y meter per second respectively. And as the time given here is 27 seconds and 17 seconds respectively, then length of the first train equals to 27x meters and length of the second train equals to 17y meters. Now as we know, when two trains are moving in opposite direction to each other, then their relative length is 27x plus 27y and the relative speed will be x plus y. That is equal to 23. Because it's given 23 is the relative time when they cross each other. Now by solving this equation, we are getting x by y equals to 3 by 2. So the required ratio is 3:2. Next question. Two trains of equal length are running on parallel lines in the same direction at 46 km per hour and 36 km per hour. The faster train passes the slower train in 36 seconds. The length of each train is, the options are 50 meter, 72 meter, 80 meter or 82 meters. The answer is option A, 50 meters. Let's see how. As the two trains are of equal length, then let the length of each train be x meters. Now as they are moving in the same direction, so then distance covered would be 2x meters. Now the relative speed between two trains moving in same direction is the difference between the two. So relative speed equals to 46 minus 36 kilometers per hour. That is equal to 10 kilometers per hour, and converting it to meter per second, we are getting it as 25 by 9 meter per second. Now here the total distance is 2x, the given time is 36 seconds and the speed that we found out is 25 by 9 meter per seconds. Now let's find the value of 2x. Distance by time equals to speed. So 2x by 36 equals to 25 by 9. That gives x equals to 50. So the length of each train equals to 50 meters. Next question. A train overtakes two persons who are walking in same direction in which the train is going at the rate of 2 km per hour and 4 km per hour and passing them completely in 9 and 10 seconds respectively. The length of the train is, the options are 45 meters, 50 meters, 54 meters or 72 meters. The right option is option B, 50 meters. Let's see how. Now first, let's convert each person's speed which is given in kilometers per hour into meters per second. That gives 2 kilometers per hour equals to 5 by 9 meter per second and 4 kilometers per hour equals to 10 by 9 meters per second. Now let the length of the train be x meters and its speed be y meters per second. Then x by y minus 5 by 9 equals to 9 and x by y minus 10 by 9 equals to 10. That means the length of the train by the relative speed of the train with respect to the first person equals to 9 seconds and the length of the train by the relative speed of the train with respect to the second person equals to 10 seconds. So here we are getting two equations. 9y minus 5 equals to x and 10 into 9y minus 10 equals to 9x. Now let's solve both these equations. Now after solving both these equations, we are getting x equals to 50. So length of the train is 50 meters. Next question. A train traveling at a speed of 75 miles per hour enters a tunnel 3.5 miles long. The train is 1/4 mile long. How long does it take for the train to pass through the tunnel from the moment the front enters to the moment the rear emerges? Now let's see the explanation. Now the total distance that the train has to cover is the total length of the tunnel and the total length of itself. That is equal to 7/2 plus 1/4 miles. That is equal to 15/4 miles. Now the given speed is 75 miles per hour. So the time taken will be distance by speed. That is equal to 15/4 by 75. That is equal to 15/4 into 75 is equal to 1/20 hours. Now converting hours into minutes, we are getting it 1/20 into 60. That is equal to 3 minutes.